In precisely the same way, for precisely the same reason that we can think of a box as having volume given by a whole bunch of squares or rectangles stacked up, we can think of a cylinder as having volume given by a whole bunch of stacked disks, stacked circles, where for that we have volume given by pi r squared h in terms of that radius, and pi to give us the area of the base value there, and h is the amount of them, the height of the overall cylinder. It's pretty straightforward. Again, it's the exact same line of thought as what we had when dealing with rectangular solids, so let's just get a quick, direct example for how this works in practice. For this, we want to get the volume of the given cylinder, where here we are given the height is 9 yards. That scaling with that perspective is a little bit wonky, and then we're told that the radius is there in terms of the diameter going to be 10 yards, because the radius is half of that diameter, 20. So for our volume, it's nothing too special. V is equal to pi, r is 10 squared, times the height of 9. So that's going to give us 900 pi cubic yards. And in a lot of contexts, I'd be okay with this as the final answer, as it were. This is the most exact answer. But for something more applied, like our previous examples, we might want to know a little bit more usably what that ends up being, that's close to 3,000 yards. To be a little bit more precise, we could say that this is something approximately 2,827 cubic yards, to be sure. And then, just like we did where we cut our boxes into pieces to get pyramids, we can cut our right cylinders into pieces to get cones. So let's talk about the volume of a cone as well.